Hello everyone. Today we're going to be looking at another property or another operation we can perform on vectors, and that's the cross product. Cross product is like the dot product, as it's a operation that can be applied to two vectors. The difference is the cross product of two vectors gives us a third vector that is perpendicular to the two vectors being crossed, and that's going to be perpendicular in 3 dimensions, in R3. So if I imagine two vectors, vector A and vector B, and these two vectors are meeting at some angle, it can be any angle. If I want to find a vector that's perpendicular to these two vectors, I'm looking for a vector that meets these two vectors at a 90-degree angle. So this perpendicular vector meets vector A at 90 degrees, and it also meets vector B at 90 degrees. If you look at this diagram and you imagine A and B are on a flat surface, the perpendicular vector would be rising out of that flat surface. When we talk about the cross product, we can write it as vector A crossed with vector B. Okay, it looks like multiplication, but when we're dealing with vectors, that's read as the cross product. And so this vector rising out of your page would be the vector A crossed with vector B. So let's talk about how we can find that. If I have vector A and I have vector B, I'd like to find A crossed with B, which means I'm looking for a third vector that's perpendicular to both A and B. We know from our dot product that a vector perpendicular to another vector would have a dot product of 0. So let's let this perpendicular vector be called vector C, and that's going to be our vector x, y, and z. We don't know what those coordinates are yet. We do know that vector A dotted with vector C is equal to 0, and vector A dotted with vector B is also equal to 0. So we can start solving this. Okay, my vector 1, 1, and 0 dotted with my vector C, which is x, y, and z, equals 0. So applying the dot product, I would get x plus y plus 0z equals 0. So I get that equation. If I do the dot product with A and C, sorry, this should be B and C. Then I have the vector 1, 3, and 1 dotted with my vector C, x, y, z. It's going to equal 0. So I get the equation x plus 3y plus z equals 0. Now I have two equations and 3 unknowns. I can work through this. I know that x has to equal negative y. So I can sub this into my second equation, negative y plus 3y plus z equals 0, or 2y equals negative z, or y equals negative 1/2 z. what's happening here is I'm not getting unique solutions. It's telling us that there are an infinite number of vectors that are perpendicular to A and B. So I could start picking some values for x and y and subbing it into these equations and making something work. For example, if I make my x value 1, my y value has to be -1. And my z value would be +2. This is a vector that would be perpendicular to both A and B. I could pick others. The bigger problem is, if we try and solve these cross-product questions this way, depending on the setup, we might be working and guessing and checking for a long time. So we want a more efficient way of doing the cross-product, because doing it this way every time is too much work. So let's look at a shortcut. If I have two vectors A and B, and I want to find A crossed with B, if I want to find that vector perpendicular to both, I'm going to do a few things. First thing I'm going to do is write out both vectors twice, and I'm going to write them out without any brackets or commas. So there's vector A written out twice, and underneath it I'm going to write out vector B, so I've written them out twice, no commas, no brackets, and I've written them out on top of each other. You can almost imagine that I've created several different columns of numbers. So my second step will be to cross out the first and the last column. Our third step is actually our tricky step. This is the part where we actually calculate A crossed with B. And to do that, we take the top left number and we multiply it by the bottom right number. So 4 times -5. And from that, I'm going to subtract the bottom left number multiplied by the top right number. So I'm subtracting 2 times 6. And that gives me my x-coordinate of a vector perpendicular to A and B. And then I move over one, and I repeat step number 3. So I take my number 6, my top left number, multiply it by -1, and I subtract -5 times 2. Okay, it's important to keep our signs straight as we do this. And again, I repeat. So to find the z-coordinate, I take the number 2, multiply it by 2, and I subtract -1 times 4. So to finish off my answer, I just need to simplify my 3 coordinates. times negative 5 is 20. Sorry, 4 times negative 5 is negative 20 minus 12. So we get negative 32 for my x-coordinate. Negative 6 plus 10 gives me a y-coordinate of positive 4. And 4 plus 4 gives me a z-coordinate of 8. So what we've done is found one specific vector that is perpendicular to both A and B. And if we wanted to, we could check this. And we would check this by taking my vector A and dotting it with this new vector, A cross B. And we'd also take vector B and we would dot it to vector A cross B, and we would see, we'd verify that both of these equal 0. And you can try that on your own. So just one more time to show you the method. If I want to find A crossed B and I have these two vectors, I start by writing out my two vectors twice on top of each other. And then I cross out the first and last column. And then I take the top left number, multiply it by the bottom right number. So I get 1 times 3. From that I subtract the bottom left number multiplied by the top right number. So I'm subtracting 7 times negative 2. And that's my x-coordinate. My y-coordinate will be negative 2 times 0, subtract 3 times 5, and my z-coordinate will be 5 times 7, subtract 0 times 1. So simplifying, 3 take away negative 14 becomes 3 plus 14. So we get a coordinate of 17, coordinate of negative 15, and a coordinate of positive 35. And this is one vector that is perpendicular to both A and B. It's one of many vectors that are perpendicular to A and B. So that's all for today's video lesson. In class, we're going to look at the properties of cross product and compare them to the properties of dot product. And I'll give you some time to continue to practice using cross product.